Hi, everyone, and welcome to today's webinar, AI Acceleration and Supply Chain Security. We're going to be talking about artifact management trends in 2026. My name is Meghan McGowan, and I cover product marketing here at Cloudsmith, and we're really glad that you're here. Today's session is built around our latest research report on the state of artifact management in 2026. The numbers tell a really clear story that AI-generated code is now nearly universal, but enforcement is lagging, and the window to get ahead of new developments is closing fast. We've brought together 3 experts to cut through the complexity and to help you walk away with a clear picture of where things stand and what to do next. So a few quick logistics. You're muted by default, but we'll have time for Q&A at the end. Drop your questions into the Q&A or chat widget at any time. This session is being recorded, and the replay will land in your inbox afterwards. And if you have any audio or video issues, just refresh your browser or rejoin using the same link. So I'm going to be your host and moderator for today's panel. We have a packed 45 minutes, so I'm not going to waste any time in introducing our amazing panelists today. I'm joined by Glenn Weinstein, our CEO, Lee Skillen, our co-founder and CTO, and Alison Sickelka, our VP of Product. So welcome to all 3 of you. Thanks for joining us today.
Thanks, Meghan.
Yeah,
Thank you.
So I'm going to kick off with the very first question, which is an exciting one. So Glenn, Cloudsmith announced last week that we've secured $72 million in Series C financing from TCV and Insight Partners. Why did these investors make such a big bet on artifact management, and why now?
The timing is interesting with the webinar and our report, the annual report, but we did just close our Series C financing, which tells me that investors, customers, analysts, and the community in general have recognized the primary importance of artifact management in securing the software supply chain. It's the business we've been in. We've been in this business for 10 plus years, but we've met the moment, and we've met the moment for a couple of reasons, 2 big factors. One is that as we've made this shift from AI-assisted coding to AI-led software development, it's really increased the pace of building. Companies are building and teams are building more often every day. They're doing more builds, they're just writing more software, and they're bringing in a wider range of dependencies. It's putting a lot of pressure on artifact management systems. And at the same time, the threat envelope has increased dramatically. This is sort of coincident with the increase in AI-led software development, but starting last August, last September or so, we in the software development community saw an unprecedented rise in attacks on public registries like NPM, PyPy, and packages in those sort of public registries. And AI-powered malicious actors are just as, they're seeing the same productivity increase that software developers are. So it's, again, putting a lot more focus and pressure on the role that artifact management systems play in securing the software supply chain. We've got great investors. We're led by, you mentioned Meghan, TCV, and Insight Partners. There was a brief moment, I think, when people thought maybe software companies are dead because people just write their own, but I think we're actually seeing the opposite. That tooling like Cloudsmith is actually more mission critical than ever.
Yeah, I think that kind of leads into my next question, which is about how you actually wrote the introduction for this report, right? It was talking about this fundamental shift. And it's kind of funny because things have probably changed even since the report came out. Things are moving so fast. So what you talked about was moving from how can AI help me write better code to moving to how can I help AI write better code, which is a really striking reframe as we think about the software development space. So what do you think this actually means in practice for engineering teams today, and why does it matter for how we think about security?
Right. Well, we're a software company ourselves. We've got a big software engineering team that writes code, and we're using the same tools as everybody else is. We're using Claude Code. We're using IDEs like Cursor. We're using OpenAI, Codex, and so forth. So we're struggling with the same kind of increase in productivity, increase in risk, increase in complexity that I think every software team is. And probably the most immediate impact on software teams is the wider range of dependencies that tend to get pulled in by AI-led development. AI agents don't necessarily know the full context of the sorts of packages, the sorts of frameworks that have been in use either by your team specifically, or maybe your wider department, or where you fit into a larger enterprise. And you end up with more what I would call like novel dependencies that maybe haven't been used before. Not as much of that senior engineer savvy about how to balance the risk and the payoff of getting into these dependency graphs. So I think you need to match that with increased automation and guardrails and context that an artifact management platform can give you.
Yeah, one of the stats, I guess, that strikes me from the report is that, we're seeing that 93% of organizations are now using AI generated code, which is a near universal adoption in a single year. It wasn't really on our radar last year when we did this report. So when you saw that number come back from the survey,
Yeah, I got a little background noise here. Sorry about that. Maybe Lee can take that question.
Sorry, what was the question again, Meghan?
Yeah, the question is about how 93% of organizations are now using AI generated code, which is such an increase in adoption in just a single year. So I guess when you hear that number, like, what's your reaction? Is that a sign of progress, or does it set off any alarm bells for you?
Yeah, it's interesting. I think for me, it's exciting. We should be very excited about progress generally. We've seen lots of eras come and go where we've made things better overall. We've done things in more clever ways and smarter ways and safer ways and faster ways. And this is something that represents that too. So the concerning part for me is it's not about AI wrote the code, because ultimately humans can also write bad code too. And whenever we did that before, we figured out ways to make that better, right? So the previous question asked about how can we help AI write better code. I think the better code part of it is definitely the right thing to do. So they're able to do things very, very fast. So the concerning part is more great. How can you adapt to that and actually help keep up with it? So the question is not whether teams should use AI or not. They absolutely should, and they absolutely will. We do, and the industry will as a whole. The question is whether that we as an industry can rally around infrastructure or tooling that can help us to do it more safely.
That's great.
Yeah, I actually thought 93% is an undercount, probably, although it's pretty close to unanimous. But my gosh, it's hard to imagine a team today in enterprises, not using some sort of AI coding tool.
That's right.
Yeah, absolutely. I think that kind of dovetails into my next question, which is for Lee, which is, you've been building in this space since before you co-founded Cloudsmith. From a technical architecture standpoint, how different is the software supply chain in 2026 compared to even 2 or 3 years ago? What's fundamentally changed under the hood, in your opinion?
Yeah, certainly whenever we started, software supply chain, even as a term, wasn't really particularly utilized. It was really more like from physical supply chain. And we talked about things like artifact management and building things and CI and CD. So only really over time we start to recognize that this is the thing that actually you should care about where your soft comes from, how it's built. But the biggest change that we're really seeing over the past couple of years is the pretty obvious one, that actually the supply chain as it was built used to be mostly human paced. So previously we wrote the code, we opened PRs, another human reviewed it sometimes, hopefully all the time. Say I built it, and then eventually we deployed an artifact somewhere. Great, it worked. That way of working was already under strain at big scale, because it was built around human review as the control point, 1 dev, 2 reviewers, that kind of thing. And AI has just changed that completely. So it increases the number of changes and also the scale and the complexity of changes. And it also makes provenance harder. Like, was this piece of code written by a human, suggested by an agent? Was it copied from somewhere? Was it assembled by a workflow? Did someone sneak it into the company? It's becoming much more harder to understand, like, the quality and safety of the code that's being written at that level of scale. So ultimately, under the hood, the supply chain has become a lot more dynamic, more automated, and also just less manually discoverable at that as a side effect of agents building large-scale software. The final thing is also makes finding and trusting good quality software. It's increasingly become like finding a needle in a haystack or a factory full of haystacks, I guess. Not that it was easy before, but it's increasingly harder now.
Yeah, the thing I would add to that, Lee, of course, there's there's no going back, right? It's still, the juice is still worth the squeeze. I don't know that I haven't heard any shops that are saying, well, we're just not going to use open source frameworks anymore. They're too critical. They add too much value. So it's more a matter of, can we figure out a better way or smarter way to configure and kind of secure our software supply chain. The idea of going back and just saying, well, it's not safe, so let's just not use it, is really a non-starter.
Well, you said it earlier on. It's like we're moving beyond us producing software to building things like software factories to help us produce the software, and that's just a different kind of engineering. Like we've seen revolutions of software engineering and applying like how do we get better quality code over time, but now we're starting to build the things that build the software, and we have to basically rethink how we apply software engineering to that. So it's a different way of thinking. You have to think more infrastructurally, more about workflow and about maximizing speed throughput in a safe way. And it's just a very, very different setup from a developer is just coding something somewhere and eventually it hits production.
Absolutely. I think this kind of ties into one of the questions that I have next, which is for Alison, actually, about how, there's one of the things that came up in our report is that there's an enforcement gap, right? So 79% of organizations are able to identify a vulnerability within about 6 hours of disclosure, but only 25% of them are actually using that data to do any sort of automated security gatekeeping. So in your opinion, why is detection so far ahead of enforcement? What do you see breaking down in the middle?
Yeah, I think I just want to reflect on something that Lee said earlier about just the scale of these problems. When Lee and Alan started Cloudsmith, part of it was that the complexity within an enterprise was already vast. And basically what AI is doing is bringing that complexity down to all other teams as well. Detection is essentially a tooling problem. You have threat intelligence, your packages, you need to know if you're exposed, what that matching looks like across that. But to actually enforce and control the usage of packages, that's really an organizational problem. And it starts to touch on things like workflow and how security and developers interact with each other and how you can develop solutions at the organizational level that lets developers stay productive while you stay secure as well. So, manual remediation maybe made sense at human development speed, was already starting to not make sense within the enterprise anyway. But with AI in the mix, the volume of decisions that need to be made have outpaced what you can keep up with. And so you're starting to look at leaning into automation and leaning into a control plane that integrates with your security stack. And so that's bringing security into the development space. And you need to figure out how you do that in a way that keeps developers productive, but helps them stay secure as well.
I just want to add one thing to that, because I think one of the changes that we've seen over time, certainly in the past couple of years, is the idea of things like software bill of materials, software composition analysis, like what goes into the software that we're building. And I think the industry's done pretty well to actually start exposing that, and it's more integrated. We've got it in the CI/CD. A lot of the times it's kind of like table stakes now to have it. But part of the problem is that whenever you've got that and nobody acts upon it, then it's sort of a bit of a shrug, so it's just like, okay, we know it's in it, but what do you actually do with that? So does it really help to know what's in it? Maybe for remediation or looking backwards, but it's probably not really enough to help prevent actual problems. So it's just an ingredient of the software supply chain. Having visibility of what goes into your software, definitely important, but it's just one part of it. You need control too.
Yeah, and Lee, you in one of your previous answers, you were talking about this idea about AI software factory, right? So one of the things that came up in the report is that only 17% of organizations have automated scanning and governance to actually catch AI specific risks, things like serialization issues or pickling vulnerabilities, hallucinated dependencies. So for the engineers who are joining us today, can you explain why some teams might be blind to these threats and what makes AI-related dependencies something new for teams to consider?
I think blindness is probably quite a strong word. I think I would hope that nobody's deliberately making unsafe choices in software, but the point is you don't know what you don't know. So it's really about exposing that. I think many teams have less visibility because their tooling was built for things like knowing packages of problems, CVEs, and prior workflows. And it's not quite that easy anymore with the introduction of AI-driven software development, just because of the speed, the scale, the complexity, and also where you're getting these from. So something like a hallucinated dependency that introduces a bad package, it might not have a CVE, so there might not be intelligence that says that actually this is a problem. If you've got something that the AI says, import this package, there may be no history of that. There may be no history associated with the package that someone might go out there and exploit it by creating it, and now you're consuming it. You might be the only person in the world or your team trying to use it. So it may not even exist yesterday. But if an agent suggests it, an attacker goes off and then actually creates that, they've got potentially access to your systems. Your build will just accept that, run it, install it quite happily, and then this is where you get things like it wasn't a hallucinated dependency, but if you think about the impact of something like Axios, or you're running something in your system, it's got access to the systems, and that's not a good thing. AI models are another example of that, where they're a different version, but of the same problem. So a model, as people utilize it, it's about weightings, it's about how you get from A to B to decide something for generating an LLM's GPT. But it's not just a big innocent blob of mathematics. Like you would just say, it's just weights, right? Depending upon the format and the way that you actually load those, they can carry different types of risks. You said one earlier on, Meghan, is like deserialization, where you just don't understand the runtime behavior of the model. If you have a model in your systems and it gets executed and a third party controls that, with deserialization risks, for example, something like Python pickle, you've got the potential to execute arbitrary code controlled by a third party in your system. So the rule just has to be super boring and strict, that actually you need automated governance. And it's just that if it crosses a boundary from the outside world, if it comes from somewhere else, then you need to combine things like identity and metadata, all the boring but useful stuff, provenance, and a policy system to make a decision that actually this is something you can trust. And that kind of thing will help make AI usable in serious environments.
Yeah, this idea of trust, I think, is something we talk about, but in the report as well, right? So we talk about moving from trust then verify to more of a verify then trust type of model, which sounds very straightforward, but in practice, Alison, I'm wondering, from your experience, what does an organization actually have to change in their tooling or their workflows maybe, or their culture to make that shift?
Towards verify then trust?
Yes.
Yeah. Similar to the earlier question, the tooling is actually the easier part. You need a private registry in the mix. You need to point your developers to a private registry instead of the public registries. You need threat intelligence in there, and you need a way to implement policies. But that workflow and culture shift is really the harder part. So essentially you're saying, I can't wait until I'm shipping to production to know if this is safe. I need to know it's safe before a developer even tries to use it. So you need to shift enforcement left, and you need to do that in a way that doesn't leave your builds or developers blocked. So you want to evaluate packages before they're ever available to your developers. And you want to do this in a way that ensures that instead of a failed request, they just never see or have access to that bad package. And in the case where a developer does need to use a package that maybe doesn't meet your security standards, you need to have a way to let them know that about that decision, and ensure that they have workflows that they can follow to request an exemption or get access to the package if they really need to do that. And you need to do this in a way that taps into automation. This can't all be a manual process. So ultimately, you want automated verification that preserves your developer productivity. You don't want to gate. You want to have some guardrails in place.
Some people call it shift left, Alison, but I think it's probably more like shift right, or maybe even shift down. That actually it's not just about one part in the time of producing the software, but how do you do it across the entire thing? Every single interaction where you produce and consume software, you should have something in place.
Yeah, I was going to say, we talk about policy and automated policy enforcement a lot, and I think that's kind of in alignment with what you were just talking about, Alison. So if we start talking a little bit more about AI and ML models as being, something that is being more and more governed by teams, that actually is the second most governed behind only Python. Our report shows, though, that only 12% of organizations are managing AI models with the same security policies they apply to their traditional binaries. So how do you think that fragmentation actually plays out as a risk in the real world?
I think some of this comes down to what's governed versus secured, and knowing you have control over those assets, those artifacts, but knowing they're safe are very different questions. And we've seen this pattern before of teams operating outside of the standard workflows that platform engineering or security use. And ultimately, having that single pane of glass where all your teams have oversight, visibility, and can apply controls is really how you can get to the point of building confidence within the enterprise that you're not exposed to some of the risks that Lee detailed out around AI models and the new artifact types. You need that single pane of glass for all the different teams working across your organization, so you can have confidence in that those same guardrails are applying no matter the artifact types teams are using.
Yeah, that's great. So one of the things, I guess, we're talking a lot about trust. So I'm going to keep kind of on that train, I guess, here, which is, one of the concepts that we talked about in the report is this idea of reputational security, the idea that teams might trust a model because it comes from a trusted source, the source that they're used to using, maybe Google or Meta, and that trust can substitute for actual technical validation. So Lee, I'm wondering how dangerous can that assumption be, and what should teams be doing differently or thinking about differently?
Yeah, I think reputation works really well in the real world whenever you've got reputation of a tradesperson that you like to rely upon, but it's probably not enough alone for software because it's hard to prove that that is that person or a thing. So reputation is just a signal, right? It's only one of the things that contribute to it, to trust in it, and it's not a control in and of itself. So this came from Google, or it came from Meta, or that came from Meta. It's useful for selection, but by itself, it's not provenance. And just trusting it blindly before verifying it just opens up everybody to a lot of unnecessary risk. You know, we've already learned this lesson in open source. Like, I'm a developer myself. Sometimes you want to make a decision as to which good package to pick, and you're often doing that, or at least you used to, based on, well, what is the most popular package? So people trust popular packages because they're popular as their main attribute, and that kind of sounds crazy whenever you say it out loud. But popularity can also make something a bigger and better target, and ironically, sometimes more risk. Some things that are more risky. Sorry, what I'm trying to say is that the things that are popular are ironically more risky, even though they're in use, because it's a good target. So yes, reputation usually means better quality, but I also agree that the technical validation of verified and trust is crucial.
I think, yeah, that makes a ton of sense. I'm kind of shifting gears here a little bit, but I think in the vein of like, okay, you need to be able to trust, and in order to be able to trust what's coming in and what you're building with, you have to have kind of like a unified control plane. And that's something that the report makes a really strong case for, of like, you know, one place to govern Python packages, Docker containers, and your ML models under that same policy engine and platform. So Alison, why do you think that unification is so crucial, and what does it actually look like in practice for a team that might be currently managing these in different silos?
Yeah, so the problem with silos isn't just inefficiency, although there's that as well, but it's that your security policies can't apply to what it doesn't know about, what they don't know about. And so if your AI models live outside of where your artifact management system or where you have policy management, then they simply don't apply to them. And the teams that are responsible for security don't have a full visibility on where the risk is. So a unified control plane gives you one policy engine, one provenance, one place to apply provenance checks, one audit trail across your open source dependencies, across your Docker containers, your Helm charts, and now your AI and ML models as well. And the same rules can apply consistently regardless of the artifact type. So that immediate benefit is consistency and actual real control over your software supply chain, the whole breadth of it, the same threat intelligence, the same policy logic. The longer term benefit is you also are audit ready. And when an incident does happen, you know where to go to understand the impact.
That's such a key point, Alison. And I think it builds on the point we talked about earlier, the enforcement gap, what you called, Meghan. Like, most organizations know they can detect vulnerabilities, but a relative minority actually have anything in place to do anything about them. And I think it's sort of what you just described, the idea of not having a central nervous system for the software supply chain, relying on individual developers, build manager or package managers, and how they've configured them, relying on pulling from public repos and then sort of hoping that by the time it gets merged in as a PR, somebody will catch it. This whole notion of moving to a central sort of control plane for the software supply chain is not a natural motion for a lot of large organizations, but it's becoming more and more critical to do something like that. Lee, we can hear you typing.
Oh, sorry.
It's a live webinar, but you know, it's the solution to a lot of the problems I think that our artifact management report highlights, are thinking about managing the software supply chain, managing artifacts as not an individual developer problem, but as a problem for the organization to handle as a service to developers.
Yeah, one other thing I just want to add to that is, like, it's the control plane centralization thing as a topic is a pretty big one. But also, it's just like for Cloudsmith and the way that we think about it, we're not trying to be all the things. Whenever you talk about a central control plane, how critical it is, it's just a really great place to put control into. So what you really want is all of the rest of the tooling and ecosystem being able to plug into that. And for us, in the way that we think about that, is about building a place where we can bring signals in, make them enforceable. We talk about this in the way that we describe things that Cloudsmith is building like an operating system, but it's something that people can build upon, partners can build upon and plug into. And that's in one single place that you've got access to.
Excellent. I think I have one more kind of like AI specific related question to like end on, which is that, both Anthropic and OpenAI have made significant enterprise pivots this year. We're seeing a lot of the enterprises adopt Anthropic with about 40% of enterprise LLM spend. What does that consolidation of AI power in the enterprise mean for how companies need to start thinking about governing their software supply chain? Either like Glenn or Lee.
That's a Lee answer that, please. Yeah. I mean, it's a multiplying force, isn't it? I think, is the question more about the outcome of having AI, or more to do with like what do we need to do to secure it, to govern it?
Well, I think the recognition that it turns out that the killer use case for LLMs is software development. I don't know that that was as obvious a year ago as it is today. Anthropic, when they made that magical pivot towards using Claude for Claude Code, OpenAI saw that and is now concentrated a lot of their resources, not just on software development, but specifically enterprise software development as a $1 trillion opportunity for how LLMs can actually make the world a better place. So it can help us build more and better software to run the world. That is a profound change in our industry. I go back to what you said at the start of the call, Lee. We fundamentally are running software factories. It is not. There's a craft to it too, but we're assembling software, and we're helping our AI agents as machines to assemble software faster and better than we ever have before. And that factory analogy, I think, is a really good one. It takes really smart people to run a factory efficiently and smartly. It doesn't do it all by itself, but it makes smart people incredibly productive when you've got these super efficient machines at our disposal. And that's I think that's the most productive way to think about the impact of AI, how Anthropic has suddenly become this multi-billion-dollar company.
Yeah, one thing I would, just going back to your question, Meghan, of what's the impact of these companies pivoting to the enterprise, it's going to be more scale and complexity within the enterprise. Our enterprises already had complex software supply chains. You're talking about 3,000 developers across an organization or more contributing into building the software. And now you have 3,000 AI-enabled developers contributing into your software supply chain. So the scale and complexity in the enterprise is just going to get more vast.
I was actually just going to add to that with a similar sort of reason. Alison was like, once the AI is in that value stream somewhere, it's like it becomes a lot harder to actually govern it with just a please be careful or just internal guidelines or informality. So the more central that AI becomes, specifically if you build in software factories, the less acceptable it is for just trust and things like that to be informal. You have to build processes into it in order to make sure that you're not at risk unnecessarily and you can act at maximum speed.
Absolutely. And I think, we're talking a bit about governing the software supply chain, and it kind of leads me into what is another section in the report, which is that regulation is catching up. The EU Cyber Resilience Act has a really important enforcement deadline coming up in September of 2026 for reporting requirements. And our report shows that 74% of organizations lack the visibility to produce audit reports quickly. Even though EU is in the name, it's actually an important regulation for any company that's selling software or hardware with a digital component into the EU. So how serious is this exposure, Glenn? Like, what are you hearing about it?
Well, we hear from our customers, we hear from prospects that are looking to buy Cloudsmith, and the CRA and the pending deadline, the September 2026 deadline for disclosure of vulnerabilities, which is all this year's deadline is about, is pressing companies into action. We see it firsthand. It goes back to this notion of automation, of having a governance structure, so that as your company discovers vulnerabilities at any stage in the software development lifecycle, whether it's something that you're currently building, it's something you built a few months ago and it deployed to production, or any permutation in between, that you've got at least the capacity to automate that reporting and kick off some workflows that help you meet your obligations under the CRA. I think it goes back to the enforcement gap, Meghan, again, that you led the call off with. Companies have a pretty good regime in place to know about vulnerabilities. They don't necessarily have a great regime to automate the workflow that those discoveries kick off. So I think it's a scramble time, basically. If you don't have that level of automation, think about how you're going to keep up with the constant demand. It really is like a change in the way that you do business. Is this not a once a year audit requirement, but a continual requirement to disclose vulnerabilities?
Yeah, I also just want to add opinion to it, but actually I think it's a really, really good thing to be pushed to do this, to have a responsibility. Like, we work in software supply chain as a company and think that we've got a responsibility to help people secure and govern the software supply chain. But it's really like, we're also a vendor. We're also building stuff that we want to ensure is trustworthy as well. And everybody really shares that responsibility. So I think being pushed into something like CRA, even though it's an additional set of things you need to do, they're very, very worthwhile if you want to minimize the actual risk to your company. So it just makes sense.
I agree, Lee. And we have several go-to analogies for, like, what do you mean by software supply chain? What is that concept? And in the one of the go-to analogies is the food chain. Restaurants source food from farmers and from other suppliers of ingredients, and we all take for granted that there are checks in place to make sure that those ingredients are healthy and won't kill us when we eat a salad at a restaurant. And the restaurateurs are the first ones to say we want to secure food supply chain. The suppliers want to secure food supply chain. It's in everybody's interests to have that. And to the extent that Cloudsmith is a player in the software supply chain ecosystem, we want that. We want a safer supply chain, and we want to know that when problems are discovered, that they will be publicized, and that the consumers of the potentially tainted software are made aware of that. Just as food has recalls and things like that, when the rare occasion happens that something bad gets out in the food supply chain, we consumers we know that we'll be told about it in a timely fashion, and we can protect ourselves.
Yeah, we're not allowed to talk about beef supply chain issues over here. It's bad memories.
I would just plus one the CRA being a good thing for the industry. I think it's interesting. We've at Cloudsmith have talked about software supply chain for a long time, but you're really seeing two things in the industry right now. You're seeing the CRA, but you're also seeing the direct result of what happens when the software supply chain exposure is made very visible with all the attacks that were happening at the end of last year and into this year. And we haven't really touched on that in this webinar yet, just that the AI development is also happening with the attackers as well, and they're getting smarter with how they're attacking the software supply chain. So it's really interesting, if those attacks hadn't happened at the end of last year and into this next year, would we be having as many software supply chain conversations with the CRA itself coming? Maybe not. But to see those attacks and then see this regulation come back to back, you're seeing a lot of people be more aware of what the actual impact of not complying with the CRA is. It's not theoretical, it's those real attacks that we've seen happening.
Absolutely. I want to make sure we leave time for questions from the audience. So I'm kind of going to move us into a last question. The top two investment priorities for 2026 is security scanning and AI ML ops infrastructure. They're each cited at about 29% of respondents in the report. So I want each of you guys to answer this question, but if a platform engineering director has budget for only one initiative this year, what's the single highest leverage thing they should do to close the gap? I guess start with you.
Go ahead, Lee.
Okay, sorry. Since I'm starting, I'll finish, I guess. But obviously, we're biased here, and part of the thing that we're talking about is artifact management. I think for a long time, artifact management has probably been underappreciated, and just the opportunity that you've got about actually having it in place. But it's been said multiple times in this webinar already, that it's a really fantastic control point. Every single artifact as part of software factories flows through artifact management, and we talked about a single centralized control plane. This is the place where you can enforce policy on everything that's passing through it. So think about this as the central scanner in the software factory. And it's not just visible, it's not just scanned, it's not just point in time, it's enforceable and it's continuous. So it's the biggest thing I think I would do. And I can expand on that, but I'll give space to the rest to talk.
Yeah, well, it's a tough one to follow, but I'm not going to argue with that. It might sound like table stakes, but 83% of organizations in our report said they're running outdated artifact management infrastructure. So it is worth saying that out loud. I also think if you look at SALSA or you look at some of the frameworks around what it looks like to secure your software supply chain, it starts by having a private registry between the public registries and your developers. And so it is the foundational starting point. And the last thing I'll say is, when we think about package management, we like to say that the flip side of that is package distribution. So that idea of your infrastructure, your ops infrastructure, your package management is part of that infrastructure and your investment in being able to make your developers and your AI workflows efficient and productive.
Couldn't agree more with everything Alison and Lee said. I would, my message, or I guess my number one thing, if I was a platform engineering leader or a CTO, is give your developers private curated registries. It is sort of crazy to think in 2026 that we expect developers to source ingredients for their software supply chain on their own, basically going to public registries. It's the equivalent of telling your chef in a restaurant, go just find ingredients wherever you can find them, like, and not having them delivered, by a trusted supplier. Is long past time to change that mindset. And it's not a tax; it's a service that companies owe to their developers.
So you're talking about making good decisions, Glenn. So this is, there's something called the paradox of choice. That the more choices that we've got, and actually the less information to make better decisions, the harder it is to actually make a choice. So by having something that allows you to actually ask the questions and make the decisions and pick good software ultimately, that's essentially what we're talking about. And your developers can do that with the most minimal amount of risk. And then they can therefore just go off and be productive at maximum speed, I guess.
Absolutely. I'll do a quick plug we have about 10 minutes. So please submit your questions. We have 3 amazing panelists ready to answer. And while we wait for maybe some of those to trickle in, I'll ask my last question to Glenn, which is, the report opens with you talking about the craft of programming and a sense of craftsmanship in programming. So as AI writes more and more of the code, what does that craftsmanship look like for engineers and architects in our audience? And where does human judgment still matter most?
I hope everyone does get a chance to download and read the 2026 Artifact Management Report. It's chock full of statistics, and it's a really interesting and very well-grounded survey. But I did write that opening myself. It was not ghostwritten or anything like that. And it goes back to my own roots as a software developer since I was in junior high school. Lee, we share that kind of super early kind of love for the craft of software development. And anybody who's been around this industry for a while has seen this evolve over time, increasing layers of abstraction that far from getting us further away from the craft, actually enhance the craft. They allow us to use our ideas and our creativity to build better software. I truly believe in my heart of hearts that is more true today than it's ever been. And that our job as vendors and our job as DevOps people is to help our developers to reach their maximum potential and don't be discouraged. Software has never written itself. It takes a really creative brain to know what to build, to know why to build it, and to know how to build it. And I haven't concerned myself with the details of machine language in a long time, and I don't miss it. And similarly, developers are not going to miss the aspects that AI automate. What they will still get is that visceral thrill of having an idea and see it come to life, and that is never going to change.
Yep. Automate the boring stuff, focus on the higher order valuable stuff, the interesting things, the big problems. And I feel the same way as Glenn, that actually this is a tool. All tools can be used for good or evil. Hopefully this one could be used for a lot more good. It is used by evil too, but that's the reason why you put something like this in place, to make sure that we can protect against it. But I'm personally just super excited about it. We should be as excited as an industry. It's not unlike being a top talent engineer at the company and then growing into engineering management. You're no longer the one necessarily writing all of the code, although you should be close to it, but you're now growing a company, a productive engineering organization that's capable of writing software, at a high quality. So it's a bit like that journey, but I'm super excited to see where the industry goes next beyond this, and we'll reach a new level. There will be something next, and we just need to level up and find out what that is.
So there are some questions. So one of them I'll lead with, because you kind of alluded to it, Lee, about, it can be used for good or for evil. So, when we talk about hallucinated dependencies, like how common are they really? And is there a way to catch them before they hit a PR?
Oh, that's great. Also slopsquatting and things like that, I think are related to this, that actually you've got AI generating stuff that may or may not be real, and like how do you then predict that or prevent it from happening? I think we've already said it, but the exact rate is going to vary by language and workflows and models, but it's something that we do see. So if AI can suggest plausible package names, then you need something to be able to understand what is plausible, what is real, what is not. And it comes back to like that trust and signaling of the verify before you trust it. The more information you have about something, that whenever AI does a thing to generate code to use a package, if you've got a system that's able to tell you, well, actually that package doesn't exist, or if it does exist, it was really just created in the past day, what other metrics contribute to this as a valuable package? So realistically, what you're talking about here is how do you make the AI make a better decision? And whenever it does make a decision, you then also can make sure it was a good one too. So you need to have a system of control in place.
I will say, Lee, that hallucinated dependencies and slopsquatting is definitely a real thing. The security researchers have shown repeatedly that as soon as a slop-squatted package is put into a public registry, you can see it consumed hundreds or thousands of times before anybody catches it and marks it as malware or what have you. I think part of security is there's only two kinds of companies: those that have been breached and those that don't know they've been breached. I think you never really know the full impact of something like that, but to know that thousands of build systems or IDs have pulled in a slop-squatter package before it's caught is just, who knows what the impact of that is. It's really scary to think about.
I think I say a lot that the best lessons are the hardest lessons, but you don't really want to learn that way by learning via the hardest lessons. So don't do that. Listen to things like this, implement something before it happens, and don't be one of those, well, we got breached and now we need to think about fixing that and not doing it again. It's a really well understood pattern, and there's things like this can help people to prevent it happening.
I think you're right, Lee. I think the notion of cool down policies probably came into vogue a little bit after the survey went out that resulted in the report that we're here talking about today. But when you think about the Cloudsmith policy engine, the apps, I think clearly the most popular kind of a policy that customers are writing are cool down policies, which basically just say don't take a package that has been published in the last few minutes. Give researchers some time to catch up. And identify problematic or unwanted packages. That's a great practical step. There's lots of others. The policy engine does a lot more than cool down policies, but that's a super straightforward way to protect yourself.
I think you're right, Glenn. That's a great generalized way of approaching something that isn't necessary for hallucinated packages themselves, but it's just one of the many tools that you've got in your tool set to be able to address problems like this at the root cause.
Excellent. I think I have one more that I'll ask the group. So I think this is related, Alison, to you mentioned something about that was in the report about how 83% of organizations are running potentially outdated artifact management systems. I'd love to know, I guess, from Glenn, your perspective, for those who maybe are, choosing to stay on-prem, maybe they don't have intentions to move to the managed cloud solution anytime soon. Often it's because they're citing security or data sovereignty type of concerns. What would you say to a CISO who believes that their legacy on-prem might be the safest option?
Well, I think first and foremost, any option is better than nothing. I think implementing an artifact management platform for many vendors is a grand idea, and you should definitely do it. We have we're in a competitive market, and I think we will tout our advantages over competitors. But for the purposes of this webinar, or just the purposes of the report that we put out, the 2026 artifact management trends, I think the overarching kind of point of urgency is just to either get an artifact management system in place, or if you have one, get the most out of it. It's only good to the extent that you use it and that you implement all of its features. So we often, I think we think about as developers or as platform engineering teams that what really matters is where we store the source code, or what really matters are the CI/CD pipelines. Well, this really matters too. And I think artifact management is as critical as any tool to the overall software factory in a company.
One thing I'll add to that is just like it is better to have something than not, but also to consider just the operational tax of running said system. So you shouldn't dismantle it, but also just think about, like, do we spend a lot of time actually maintaining, running, keeping it up to date, and so forth. And obviously our domain is that we believe in cloud native infrastructure out of managed tooling, and we would always recommend, at least this is the way that we run at stuff, is that you've got a particular domain that you're experts at, but there's certain things you can trust other companies to build, run, maintain, and keep it up to date for you. And obviously that's the domain that we're in for artifact management.
Yeah, you're right, Lee. I was coming out of my shoes to say I'm a by the way, cloud, but for the first time in my life, I actually restrained myself. And of course, yeah, we're pretty, look at the name of our company, Cloudsmith, we're sort of big believers that the cloud approach is actually the best. But I stand by my point, though. Having any artifact management system in place is a critical part of the equation. And if you can't change vendors or you're limited in your choices, that's fine, but have something in place.
Excellent. Well, I've done my best to keep us on time for this webinar, and we are at time. So I don't know if like Glenn, Lee, or Allison, if you have any closing remarks, but thank you for your time. I really appreciated your insights, and thank you to everyone who dialed in. And you'll get the recording after this, and we hope you have a great day.
Yeah, I would just say it was very much in the Cloudsmith ethos to end on time. So great work there, Meghan.
Nice work, Meghan. Well moderated.
Thank you very much.
Thank you.
Thank you for listening, everybody.